triangle inequality. If A comma B fall in R, then modulus of A plus B less than or plus mod A plus mod B. So how? So this is a triangle inequality. The proof is done by, we have minus mod A less than or equals A less than or equals mod A. Again minus mod B less than or equals B less than or equals mod B. If you add in vertically, so you have minus of mod A plus mod B less than or equals A plus B less than or equals mod A plus mod B. So from here, that is clearly modulus of A plus B less than or equals mod A plus mod B. Agree? So, by using this result, we prove another one. If A and B are reals, if A comma B, A and B are reals, then modulus of mod A minus mod B less than or equals modulus of A minus B. Modulus of mod A minus mod B less than or equals modulus of A minus B. How? This is proved by, its proof is done in this way. We have A equals A minus B plus B. A equals A minus B plus B. So we have mod A equals modulus of A minus B plus B. By using triangle inequality, it is less than or equals mod A minus B plus mod B. That means bring mod B to the left side. Mod A minus mod B less than or equals modulus of A minus B, mark it as 1. Again, similarly, what is B? B can be rewritten as B minus A plus A. So, by using the above arguments, we have mod B less than or equals modulus of B minus A. Modulus of B minus A means modulus of A minus B plus mod A. That means mod B minus mod A less than or equals modulus of A minus B or B minus A. This means bring minus outside, minus of mod A minus mod B less than or equals modulus of A minus B. So that means multiplying on both sides by this minus, so it is mod A minus mod B greater than or equals minus of modulus of A minus B. So combines, mark it as 2. Combines these two, so you have modulus of, means if you combines, you have modulus of, minus of modulus of A minus B less than or equals modulus of A minus mod B less than or equals modulus of A minus B. Minus of mod A minus B less than or equals mod A minus mod B less than or equals mod A minus B. So combines these two results, this one and this two. These two results. So you have modulus of mod A minus mod B less than or equals mod A minus modulus of mod A minus mod B less than or equals mod A minus B. Agreed. So now let us discuss about now for only A and B fall in R. What about the modulus of A minus B and A mod A plus mod B? We have modulus of A minus B less than or equals mod A plus mod B. This is another result. Modulus of A minus B less than or equals mod A plus mod B for all A and B are reals. So this is immediate. Why? Because what about modulus of A minus B? Modulus of A minus B can be written as modulus of A plus minus B. So by using triangular inequality, it is mod A plus modulus of minus B that equals mod A plus mod B. So finally mod A minus B less than or equals mod A plus mod B. This is the another result. So, by using these arguments, consider some problems. Determine the set E equals a set of all x of all n R such that modulus of 2x plus 3 strictly less than 7. Determine the set of A of x of all n R such that modulus of 2x plus 3 strictly less than 7. So, what is here? A equals a set of all x of all n R such that modulus of 2x plus 3 less than 7 means it is minus 7 less than 2x plus 3 less than 7. That equals set of all x of all n R such that then add a minus 3 on both sides, add a minus 3, but you get minus 7 plus minus 3, that is minus 10 less than 2x plus 3 minus 3, 2x less than 7 plus minus 3 means 4. So that equals a set of all x of all n R such that it is dividing throughout by 2, so it is minus 5 less than x less than 2. So A equals a set of all x of all n R such that minus 5 less than x less than 2. That means actually A equals a open interval minus 5 to, if it is in the form of an interval. Okay. Now consider another one. If consider f of set of A equals a set of all x of all n R such that 2x square plus 3x plus 1 by 2x minus 1. So consider another problem. Let a function f is defined as f of x equals 2x square plus 3x plus 1 divided by 2x minus 1. Come on, x differs from 1 by 2. If x equals 1 by 2, this does not exist. 2 less than or equals x, 2 less than or equals x less than or equals 3. Find the constant m such that mod f of x less than or equals m, where x ranges from 2 to 3. Define a function f of x equals 2x square plus 3x plus 1 by 2x minus 1. Then find the constant m satisfies the condition mod f of x less than or equals m, where x ranges from 2 to 3. So actually f of x is given. So what is mod f of x? Mod f of x equals mod a by b. Mod a by b means mod a by mod b. Mod 2x square plus 3x plus 1 divided by modulus of 2x minus 1. Now come to the numerator. Mod 2x square plus 3x plus 1 less than or equals triangle inequality. It is 2 into mod x square plus 3 into mod x plus mod 1. Then x has maximum value. X has maximum value 3. So x has maximum value 3. Then what is m? M be the largest real value which satisfies this condition. So for the largest one, then consider this numerator 2x square plus 3x plus 1. Then x has the large value. The largest means the x presents in close to 3. So the right end point, put x equals 3. What you get? It is equals 2 into 3 square. 2 into 3 square plus 3 into 3 plus 1 equals it is 28. Again, consider modulus of 2x minus 1. Mod 2x minus 1, it is greater than or equals, yes, mod 2x minus 1 greater than or equals mod 2x minus 1. Okay, so that is greater than or equals 2 into the least value of x, 2. So 2 into 2 minus 1 equals 3. Therefore, modulus of f of x less than or equals mod 2x square plus 3x plus 1 less than or equals 28, numerator less than or equals 28 and denominator is 3. So mod f of x less than or equals 28 by 3. So the value of m is 28 by 3 itself. So these are the some results depends upon our results with the results about these inequalities. Now consider the real line. What is actually a real line? Real line. Real line means that's a familiar and convenient geometric interpretation of the real number system is the real line. A familiar and convenient geometrical interpretation of the real number system is real line. This is real line. This minus infinity to plus infinity 0. It is the real line. So familiar and convenient geometrical interpretation of real number system. Now, so what about in real number system? What is mod A? Mod A is, if A is here, mod A is the distance of A from this origin. Y is the 0, Y is the origin. So mod A means the distance of an element or distance of number A from the origin. If here it is minus A, again mod A is the distance of that A from the origin. Now we define an epsilon neighborhood. That's a new term. Epsilon neighborhood of an element. What is an epsilon neighborhood? So for epsilon is usually epsilon is chosen as a positive quantity. So let epsilon positive and A presents in R. A is any real number. Then the epsilon neighborhood of A, epsilon neighborhood of A, comma, it is usually denoted by V epsilon of A. Epsilon neighborhood of A is usually denoted by V epsilon A of A and is defined as V epsilon of A equals set of all x of all in R such that modulus of x minus A strictly less than epsilon. This is the epsilon neighborhood of A. That is set of all x of all in R such that this minus epsilon less than x minus A less than epsilon. That equals set of all x of all in R such that A minus epsilon less than x less than A plus epsilon. That means x fall in open interval A minus epsilon A plus epsilon. Agreed. So this is V epsilon of A. V epsilon of A equals set of all open interval, it is open interval A minus epsilon, V epsilon A equals open interval A minus epsilon A plus epsilon. Means consider this real number system, real line. So if this is A, then this is A plus epsilon and this is A minus epsilon. So this is the epsilon neighborhood of A. So epsilon neighborhood, that is heavily depends upon epsilon itself. This is epsilon neighborhood of any element. It is denoted by V epsilon of that element and that is a set of all x of all in R such that modulus of x minus A is strictly less than epsilon. Moreover, V epsilon A equals open interval A minus epsilon A plus epsilon. So if x of all in V epsilon A, what happens? X of all in V epsilon A means modulus of x minus A strictly less than epsilon by using this definition. If x of all in V epsilon A, then mod x minus A strictly less than epsilon. What is epsilon? Epsilon being arbitrary, it is positive. Epsilon being arbitrary, so it is modulus of x minus A less than epsilon means x equals A. So this is a crucial point. If x of all in V epsilon A, then x equals A itself. Agreed. Now consider this epsilon neighborhood of a number. Then find an epsilon neighborhood of find a epsilon neighborhood of 2, epsilon neighborhood of 2 if epsilon equals 1 by 2. Find the epsilon neighborhood of 2 if epsilon equals 1 by 2. So how we have come to the definition? V epsilon A equals set of all, come on, x of all in R such that modulus of x minus A strictly less than epsilon. So for all epsilon is positive. Here epsilon equals 1 by 2. 1 by 2 is a positive quantity. So V 1 by 2 of 2 is the requirement. Epsilon neighborhood of 2 when epsilon is half means V 1 by 2 of 2. What is V 1 by 2 of 2? There is set of all x of all in R such that modulus of x minus A means modulus of A instead of A, here it is 2. Modulus of x minus 2 strictly less than epsilon. Epsilon means half. That equals set of all x of all in R such that minus 1 by 2 less than x minus less 2 less than 1 by 2 equals set of all x of all in R such that adding 2, so 2 minus 1 by 2, adding 2 minus 1 by 2 means yes 3 by 2 less than x less than 5 by 2. Agree? So for set of all x of all in R such that 3 by 2 less than x less than 5 by 2 means x lies in between 3 by 2 and 5 by 2. So epsilon neighborhood where of 2 where epsilon is half is open interval 3 by 2 5 by 2. So you can find out the epsilon neighborhood of any number when epsilon is given. That is heavily depends upon epsilon itself. Okay. Now, if epsilon neighborhood of if x and y presents in epsilon neighborhood of if x and y presents in epsilon neighborhood of a and b respectively, then x plus y presents in the 2 epsilon neighborhood of a plus b. 2 epsilon neighborhood of a plus b, not epsilon neighborhood of a plus b. If x and y presents in epsilon neighborhood of a and b respectively, x presents in epsilon neighborhood of a and y presents in epsilon neighborhood of b, then x plus y presents in 2 epsilon neighborhood of a plus b. It is not necessarily epsilon neighborhood of a plus b. How? X presents in epsilon neighborhood of for proof. X fall in epsilon neighborhood of a means for all x fall in R with the modulus of x minus a strictly less than epsilon. And y fall in epsilon neighborhood of b means modulus of y minus b again strictly less than epsilon. Now, what about the modulus of, consider modulus of x plus y minus of a plus b. Modulus of x plus y minus of a plus b equals modulus of x minus a plus y minus b. Using triangle inequality, it is less than or equals mod x minus a plus mod y minus b. It is mod x minus a strictly less than epsilon plus epsilon equals to epsilon. Means modulus of x plus y minus of a plus b less than 2 epsilon. That means x plus y belongs to 2 epsilon neighborhood of a plus b. So this is our conclusion.